Hello friends, in today's question, two blocks of masses m1 and m2 connected to each other by a massless inextensible string of length 0.3 meter are placed along a diameter of a turntable. The coefficient of friction between the table and m1 is 0.5 while there is no friction between m2 and the table. The table is rotating with an angular velocity of 10 radian per second about a vertical axis passing through its center. The masses are placed along the diameter of the table on either side of center O such that mass m1 is at a distance of 0.124 meter from O. The masses are observed to be at rest with respect to observer on the turntable. So we are going to find out these three things. Calculate the frictional force on m1. What should be the minimum angular speed of the turntable so that the masses will slip from their position, and C, how should the masses be placed with the string remaining taut so that there is no frictional force acting on mass m1. So let us draw basic figure. So we have a turntable and this is center O. Two masses are connected diagonally. Let us call this as m1 and this as m2. And m1 and m2 are at a distance that is given as 0.3 meter, and let us call that r. And the respective distance from the center is r1, and let us call this as r2, and it is in this direction with the angular velocity omega. So we are given that m1 is 10 kg, m2 is 5 kg, and the total distance r is given as 0.3 meter. And it is also given that m1 is at a distance, so r1 is also given. So r1 is given as 0.124 meter. So from here we can calculate our r2. So r2 will be equal to r minus r1, which means 0.3 minus 0.124 meter. So we can say our r2 will be coming equal to as 0.176 meters. So let's start with part A, and it is said that masses are observed to be at rest with respect to observer on the turntable. You can say masses are at rest with respect to the table. Masses m1 and m2 are at rest with respect to table. So let us draw the forces which will be acting on it. So this is mass m1. It is connected with a string, so there will be a tension T here, and similarly there will be a tension T also for mass m2, and a frictional force Fr toward the center. So this is our center O. So we can say that our m1 r1 omega square is greater than m2 r2 omega 2 square, and tension T is given as M2 R2 omega 2 square for block M2. From here we can say that tension T will be greater than M1 R1 omega square. Okay, and the frictional force will be also acting towards center, and frictional force Fr will be acting toward center O. So these are some basic things. Now let's write the equation for M1 as well as for M2. So we can say for M2 we have already written, let me write it here. So we can say for M2 we have tension T is equal to M2 R2 omega square, and for M1 we are going to have T plus Fr is equal to M1 R1 omega square. So from here we simply substitute the value of T, that is equation number 1 and equation number 2. So using equation 1 in equation 2, we get Fr is equal to, this will be our omega square, we can take common, we have M1 R1 minus M2 R2. So we substitute the values. Omega is given as 10, so we can say Fr is 10 square, M1 is 10 kg, R1 is 0.124 minus M2 is 5 and R2 is our 0.16. So we get the frictional force Fr will be coming equal to as 36 Newton. So this is our first part. Now let's do the second part. It says that what should be the minimum value of the turntable so that the masses will slip from this position. Okay, you can say masses will slip from the position if the frictional force that is Fr is greater than Fr max, or we can say equal to. Okay, so under this condition the masses are going to slip. So we already know the equation for Fr, so we substitute it here. So we can say our Fr is omega square M1 R1 minus M2 R2 is greater than equal to, and the frictional force is for M1. So this is our M1. In the downward direction we are going to have M1G. In upward there will be a normal N, that is called N1. So the maximum value Fr max will be equal to mu into N1, where N1 is equal to M1G. We substitute here, this is M1G. Therefore we need the minimum value. You can say the minimum value of angular speed is W minimum, and this W minimum will be equal to mu m1g and divided by m1 r1 minus m2 r2 and its square root. So we substitute the values. Minimum mu is given as 0.5, m1 is our 10 kg, g is 9.8, and divided by it will be m1 r1, that is 10 into 124 minus 5 into 0.176 and its square root. So from here we get that minimum angular speed is 11.67 radian per second. Okay, so this is the minimum angular speed. Minimum angular speed. And in the third part, we are supposed to find out how should the masses be placed with the string remaining taut so that there is no frictional force acting on mass m1. So in this case, you can say that the frictional force Fr should be equal to 0. Okay. Therefore, in the third part, there should be no frictional force. Frictional force on m1, that is Fr, should be equal to 0. And under this condition, if Fr is 0, we can say that therefore we already know the equation of Fr, that is this equation. So substituting here, we get that therefore you can say omega square m1 r1 minus m2 r2 is equal to 0. So therefore from here we can say that m1 r1 is equal to m2 r2, and we find out the ratio r1 upon r2 is equal to m2 upon m1. m2 is 5 and m1 is 10. So we get r1 upon r2 is equal to 1.2. And it is also given that there is sum, but r1 plus r2 is equal to 0.3. Now we can calculate the respective value of r1 and r2. So from here we can say that r1 will be equal to 0.1 meters, meters or centimeters, meters, and r2 will be coming as 0.2 meters. So from the center, if this is center O, and this is our m1, and this will be our m2, so r1, and this will be r2. So r1 is 0.1 meter and r2 is 0.2 meters. So this completes the question. Thank you.